Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 18, Atoms, Molecules, and Ions, Part 5. Going to be talking about polyatomic ions in today's video. Pause here. So polyatomic ions, these are groups of atoms that are covalently bonded to one another, but they have a net charge. So carbonate, so that is a carbon surrounded by 3 oxygen atoms. 2 of those oxygen atoms have a charge of -1, but carbonate just works as one unit. Same for sulfate. You've seen phosphate before in ATP. So you've seen polyatomic ions many places before, but you might not have known what they were. Pause here. This is a typo. You're going to determine if they're type 1 or type 3. Wait, no, that's not a typo. What am I talking about? So you're first going to determine if they're type 1 or type 2. The way that you do that is if the cation is a transition metal, then it is type 2. And if the cation is not a transition metal, then it is type 1. And then otherwise, you're going to follow the naming rules as per usual, except you do not need to change the suffix of the polyatomic ion. It is already done for you. For Chemistry 10HH, I do not require that you memorize the polyatomic ions. That does change if you take AP Chem, but for right now, I'll be giving you a list of polyatomic ions. Pause here. Okay, so Na2PO4, that should be Na3PO4, actually, so I'm going to change that. So this is type 1, so it is sodium, PO4. I find on my polyatomic ion sheet, it is phosphate. FeCN2. So I need to first determine the charge of cyanide. So Cn minus is cyanide. That means that Fe must have a charge of +2 to balance it out. So this is iron 2 cyanide. And then I've got NH4Cl. So NH4, that is actually a polyatomic ion. So I'm going to treat this like this is a type 1. So this is ammonium and then chloride. Pause here. Okay, I'll work through this. So calcium hydroxide, this is type 1. So I need to have twice as many hydroxides as I do calcium because of the +2 charge of calcium. So whenever some of you are probably wondering, why did I do the parentheses? The reason why I did the parentheses is because when I am putting that subscript down, I don't want it to just apply to one of the atoms that's in there. I want it to apply to all of them. So when I have CaOH2 in parentheses, that's really, what that really means is that I have calcium and I've got 2 oxygens and I've got 2 hydrogens. You can't write it like that, but that's just conceptually what it means. Whereas if I didn't have that parentheses there, that 2 would only apply to the hydrogen, so it would give it a fundamentally different formula. Okay, then for magnesium carbonate, magnesium has a charge of 2+, carbonate has a charge of 2-, so just MgCO3. I only need parentheses if I am pulling a subscript to apply to an entire polyatomic ion. Aluminum dichromate, I actually don't have dichromate memorized, so it has a 2- charge. So I just need to make sure that those charges are balanced. Okay, thank you so much for watching and have a great night.